Here's the basic design circuitry which you can use to drive almost any coil. I will try to explain it as simply as possible. At first, you will need a clock source. It could be an Arduino, ESP32, any microcontroller, a function generator, or even an inverting Schmitt-Trigger would work. Here, the potentiometer and the capacitor controls the output clock. This output will go into the gate drivers. It has to be an inverting and a non-inverting gate driver. So for example, you could use a UCC 27321 or UCC 27322. So your input 0 to 3.3 volts or 0 to 5 volts. At output you will get 0 to 12 volts. So this is non-inverting and this is the inverting waveform. This will go into your gate drive transformer. We basically use this gate drive transformer to isolate this low power circuitry from this high power circuitry. The output of gate drive transformer will go into your H-bridge or inverter. You could use 15 to 220 volts or whatever voltage that you want to use. And you can use MOSFETs or IGBTs in your H-bridge. It doesn't matter. And the output of your H-bridge will go to your primary of your Tesla coil, your induction heater, or your flyback transformer, any coil that you want to drive. So here's the circuitry that I'm gonna be using today. So you got your ESP32 for clock, your gate driver chips. The clock from ESP32 goes here and here. The enable pins are tied to 5 volts. The output of the gate driver chips here and here, and I'm using these diodes to clamp the output voltage. This will go into the gate drive transformer. So here's the circuitry that we just talked about. I'm not using most of it. I'm just using ESP32 and the 2 gate driver chips here and here. The output of gate driver chips goes into the GDT here, and the output of GDT goes into the H-bridge. This is a MOSFET H-bridge. I'm using this MOSFET H-bridge to drive this IGBT H-bridge because these 2 gate driver chips are not powerful enough to drive this IGBT H-bridge directly. You can just use the MOSFET H-bridge if you don't want a lot of power. And this is just a filter circuit. The input power comes here, rectified, and goes into this H-bridge, IGBT H-bridge. So this is the flyback transformer test. 7 turns primary and 1550 turns on the secondary. I'm gonna show you at 2 different voltages, at 35 volts and at 60 volts. So I'm gonna turn it on for 5 seconds. So this is the induction heater with 7 turns on the coil. I'm going to turn on the circuit now. Now I'm going to use the same circuit for Tesla coil and just turn it on for like 5 seconds. ground wire was kind of near to the mains wire, that's why there was a kind of fire. Yeah, but it's all good, no big deal, but the circuit works.